It's time for some syntheses. We said even if you suck at synthesis, you can do aromatic synthesis. Students generally don't like synthesis problems. I know, I've been doing this for a while, but you can do aromatic synthesis. I believe in you. The way you should approach them, this group, that group is an activator or a deactivator. It's an activator. That's a C. It's an ortho-para-director. Okay. This group is an activator or deactivator. It's a deactivator because it has a legit positive on that benzylic spot. It's a meta-director. And what's the relationship between these two groups? They are para. That means put the para-director on first. Okay, I can do that. Synthesize the following from benzene. If you start with benzene, put the para-director on first because they're para to each other. So I'm going to put on my carbon group. That's not anything. I'm going to put on my carbon group like so. And then I'm going to put on my nitro. HNO3, H2SO4. Nitric and sulfuric acid, para, nitro, toluene. Done. Okay. This one is a deactivator, a weird one, but an ortho-para-director. Alrighty. This one is a legit positive in that benzylic spot. It's also a deactivator. It's an electron withdrawing group. It's a meta-director. And the relationship between these two groups is that they are meta. Put the meta-director on first. How do you get these groups to go meta? You put the meta-director on first. What that means is benzene. Add my meta-director. It goes here. And then add my bromine. It goes meta. Yeah. You have to fill in the reagents, and I'm going to fill them in for you. But really, you should know these reagents like the back of your hand, right? There's a lot of other reagents that we do kind of get a little confused about, but these ones, there's really only 5 big ones, so, you might be looking and say, isn't that supposed to be Br3? Well, Br3 is not really a stable compound, so you actually just put liquid Br2, red liquid stuff, and some iron shavings. You just shave a little bit of metal iron into your flask, and it will in situ create FeBr3, but you can write FeBr3, whatever. Okie dokie. This one is an activator because it's a plain carbon. It's an electron donor. It's an ortho-para-director. This one, this is my 3rd example in a row with a nitro group. It's got a legit positive. It's a deactivator. It's a meta-director. And the relationship is that these are ortho. Put the ortho-director on first. Okay, that looks like this. Benzene. I'm ready to put my ortho-director on first. That's this big group. We can do it with any reaction that makes a carbocation, but this is some of the favorites among Friedel-Crafts. Alkylation. Then I put my nitro group on, and it goes ortho, and you say, I wish I had a sound effect for that. That's not good. Because this group up here is large, you cannot expect that nitro to go ortho as the major product. Would you get a little bit of credit for this? Maybe a little bit, but only a little bit. How can you force something to go ortho? What if I had a sulfonic acid as a protecting group? Yeah, if I protect the para position, then I can nitrate sulfonic acid is still down there. And then I can superheated steam make that sulfonic acid go away. So even though we had to go a roundabout, oops, that's not supposed to be there. Even though we had to go a roundabout way, this example, this type of synthesis is very doable because we know our ortho-meta-para directors like the back of our hand, don't we? Yeah. Even if you suck at synthesis, students can generally do aromatic synthesis okay. You should practice them, though, for sure, for sure, for sure. All right. This one. This is benzoic lone pair, activator, electron donor, orthopara. This is deactivator, orthopara. And they are meta to each other. Uh-oh. It's about this time I start screaming, put the meta director on first. And you say, I don't have a meta director. And I say, let's pause on that one and move along to the next one. Here's a group. It's got a legit positive, so it's a deactivator. It's a meta. Okay. And this one, it's got a partial positive, so it's a deactivator. It's a meta. And the relationship to each other is that they are para. Put the para director on. We got a problem here. In both of these syntheses, our groups are not where we need them to be. So then I ask, could any of these groups, like could either of these groups, used to have been a para director? Could either of these groups used to have been a meta director? So you've seen this slide before. In this group, what directing influence does, come on, clicky, clicky. What directing influence does an acyl group have? Is it an activator or a deactivator? An acyl group, partial positive, deactivator, meta. What directing influence does an alkyl group have? Plain carbon, donor by hyperconjugation, activator, orthopara. So I can turn my meta director into an orthopara director. Interesting. What kind of directing influences does a nitro group have? Partial, legit positive, deactivator, meta. What kind of, directing influence does an amino group have? Benzylic lone pair, activator, donor, orthopara. I can turn my meta director into an orthopara director. Okay. What kind of directing influences does an alkyl group have? We've actually already answered that one. It's got a plain carbon, hyperconjugation, donor, activator, orthopara. And remember, the product of this is benzoic acid. So what about a carboxy group? That's a partial positive. That's a deactivator. That's a meta director. So I can turn my activator into a deactivator. I can turn my orthopara into a meta. So if we go back and I ask my question again, could either of these used to have been a para director? Since these are para to each other, could either of these used to have been a para director? The answer is yes. Which one could have used to have been a para director? That guy. So what that is going to mean now is, starting with benzene, put the para director on first. Okay, I'm going to choose to put on this group. It doesn't matter. It's not going to matter in the long run because I'm going to Pac-Man it away anyway. So I put on this group. And then I do not do the Pac-Man reaction yet, because if I did the Pac-Man reaction now, it's too soon. My next group, my nitro, would end up meta. I need to make sure that I add my nitro while I still have a para director present, so that my nitro group goes para. I chose this big-ish group to try to guarantee that I would get more para than ortho product. If this were just a toluene, remember, ortho starts to be the major product there. Yeah. Then I chew away carbons and get rid of those two isopropyl fork ends here and here. And I need a vigorous oxidizing agent in order to do that. And one of my favoriteest vigorous oxidizing agents is chromic acid and heat. Chromic acid, remember, you don't have to acidify later. Yep. Isn't it lovely? It's great. Could either of these used to have been a meta director? Because these are meta to each other. Could either of them used to have been a meta director? Uh-huh. This one could have used to have been a meta director. Put the meta director on first. Benzene. Put on the meta director. That NH2 could have used to have been an NO2, and that comes on with nitric acid and sulfuric acid. And then I add my chlorine before I do my reduction with fecal. Ew. Before I do my reduction, I need to add my chlorine because I need that chlorine to go meta, and then I do my reduction. Sure, H2PD works just fine. There are several reagents that would reduce that nitro to an amine, but that's just the one I chose. Yep. One quick note about synthesis. We saw this slide before, but we didn't exactly know what it meant before. This says, doesn't work with strong electron withdrawing groups on the ring. So at the time, we said that meant no reaction right here. That's an N. No reaction right here. Why no reaction? Because this is a meta director. And these reagents, these conditions are too extreme. This benzene is too deactivated in order to add a carbon group on there. The truth is no Friedel-Crafts on a ring with a meta director. That's Friedel-Crafts alkylation or Friedel-Crafts acylation. No Friedel-Crafts on a ring with a meta director. So if you have a carbon group on your benzene that you're trying to synthesize, what that really translates to is you want to get that carbon group on the benzene very early in the synthesis, because if you ever add a meta director, that thing's too deactivated to add another carbon group or add a carbon group. All right, we walked through a lot of syntheses. You should practice a lot of syntheses. I'm going to make you do some. It'll be fun.